You can see from the change in format, I've once again had a problem with Microsoft's Movie Maker. I think this time I've learned my lesson. Religiously from now on I will never multitask while Microsoft's Movie Maker is pre-processing, because that's when the files corrupt, the software is not robust, which is really annoying. Other software I use tends to be robust in the sense I can multitask, but this is the umpteenth time this has happened, so I think the cause last time, or for this problem, was me switching on my iPad. Anyway, so hopefully from now on this kind of thing will no longer occur. So you would think that by re-downloading the raw film from the camcorder to the laptop and just going through the whole process again, that would solve the problem. I would not have to re-film as I'm doing now. Just do the whole thing over again. But no, it remains corrupt. Even the freshly downloaded, the software says it's corrupted. So there's some residual memory there from the previous attempt somehow. So to hell with it. So I'm refilming. Hopefully the last time. Okay, so it's just a little piece. I'll get myself out of the. It's just one square now, zoomed. The main, so this last part of this first session is, the keyword is configuration. Here. And basically what is that? Well, at any particular moment, the Turing machine executes in steps, right? It looks at its current state. It looks at, it reads the contents, the symbol in the square over which the header is placed. So it gets those two bits of information, the current state and the current tape square contents, the symbol. And using those two, it consults its transition table, its transition function, to find out what its next move is, what its next step is. And the transition function will provide it with an ordered triple, which is sort of the instructions of what to do next. So there's a bit of revision. The ordered triple, so the first item in the triple is the next state. The second one is the symbol to be written on the current position, on the current square, that the head, the read-write head, is over on the tape, right? So that the character to be written, which means that the old character gets overwritten. And the third thing is the move. Do you move left or right? Okay. So that means at any moment before the next step gets executed, that the Turing machine is in a certain condition, let's say, and this condition, the technical term we'll give for it, is configuration. And what that means is you need to specify what the configuration is of a Turing machine at any given moment, because the configuration will change step by step. At each step there'll be a new configuration. Okay. So if you tell someone what the configuration of your Turing machine is at a given moment, at a given step, because it changes step by step, you will supply 3 bits of information, three items, 3 things of information. 1, the current state. What else? The current contents on the tape, because that will change from step to step, of course, because it's getting written on all the time. So the current state, the current contents on the tape, the whole tape. Well, forget the blanks, but the whole tape. And the third thing is the current head position. You know, where is the head? Okay. So configuration consists of those three. Specifying the configuration means telling somebody what those three items are. So here they are. Okay. So the current state, the current tape contents. You know, what's on the tape, and the current head position. Those three things, they are, you know, together, the configuration. Right. Now, common sense says with the next step in the operation, the operation of the Turing machine, the next state will change, right? So the state will change. It'll go to the next state. The tape contents will change because it's been written on, okay, and the head position will change because it gets moved left or right, okay. So the configuration gets changed every step. Now, this concept of configuration is very useful, extremely useful, and so a kind of shorthand way of writing it down has been found, and basically it looks like this. So just UQV, that's it, right? You can specify the whole configuration, you know, all three items, you know, the current state, current tape contents, and current head position. All three of those things are in this short little, what do you call it, phrase or something. Just, well, I don't want to call it string. That's confusing. So this thing, UQV, right? So how to interpret this? Now, if you see something like this, that is a configuration. Okay. So how do you extract the three bits, the three items of information? You know, current state, current tape contents, current head position. How do you extract those three things from this? Well, in the following way. Firstly, let's specify what these things are. The Q is the current state. Okay? So you just look at the middle one to find the current state. So that gives you A here, what the current state is. It's the middle symbol. And the current tape contents, you concatenate these two strings. U and V are strings. And what's their alphabet? The tape alphabet. Okay? Not the input string alphabet, not the starting string alphabet, but the tape alphabet. In other words, it could include the empty string, epsilon, okay, and maybe other symbols that are not in the initial string alphabet. Okay, so the tape contents, you just concatenate the strings UV, so you get this, right? And you may ask, you know, well, it seems a bit strange. Why do you split it up and whatnot? Well, okay, so because of the third thing. Now, the third thing is the current head position. Well, by convention, the head position you find from where the Q is positioned. Now, the Q is sort of in the. It has a string U to the left and a string V to the right, and you know where the head position is by the position of where this Q is, and the head position is said to be positioned over the first character on the left, of these left, the first, well, the left-hand character, if you like, of the string V. Okay. So, well, that's what it's saying here. Now, the next session, I'll give you an actual example of this kind of thing. So, summarizing a bit, right? The notion of a configuration contains these three bits of information: the current state, the current tape contents, and the current head position. If you're given those three things, you are given the configuration of the Turing machine at that moment, at that step, and the configuration will change at each step, right? Because the Turing machine just goes through a whole series of steps. And so you'll have a whole sequence of configurations, step by step. Each new step, another configuration. So it's sort of one-to-one, all right? And you write the configuration in a kind of shorthand, like this, UQV. You look at the middle symbol here, the Q, that's your current state. To know the current contents of the tape, you concatenate UV, these two strings, UV. So that's the contents of the tape. And you know the position of the head by looking at the first symbol of your V, and the head is over that the square containing that first, leftmost symbol of V, of the string V, right? So that's it. Ciao.